Hi, my name is Phakpoom Chinprutthiwong from Texas A&M University. Today, I'm going to present security study of service worker cross-site scripting. This is a joint work with Vardhan, GuangLiang, and my advisor, Guofei. In recent years, you may have heard of the name Progressive Web App or PWA. A progressive web app is essentially a website that can act like a native mobile app. Google and Microsoft have been pushing for the adoption and development of progressive web apps to advance the web into the next generation. Currently, a progressive web app is known to support two core features: offline usage and push notification. These features are enabled using a service worker. In this work, we discover a new attack, which we call service worker cross-site scripting. We found 40 popular websites with more than 100 million monthly visits vulnerable to this attack. A service worker is a type of web worker whose job is to execute parallel tasks in a separate thread from the main web page. However, a service worker contains a set of unique features that do not exist in a web worker or even the main web page. This is to accommodate the offline usage and instant push notification. To support offline usage, a service worker can intercept and modify network requests and response of a website through the fetch event. This can similarly allow an attacker to utilize a service worker in a man-in-the-middle attack if the service worker is compromised. Furthermore, to support push notification, which can come spontaneously, a service worker can be activated and run in the background without the presence of a corresponding web page. Once a service worker is installed, it will persist across sessions and will not get replaced until a different service worker file is detected. This behavior allows an attacker to turn a temporary attack into a persistent attack by compromising a service worker. To install a service worker, a website can call navigator.serviceworker.register or register function in short, and specify a path to a service worker, which is essentially a JavaScript file. Although the service worker file must be from the same origin, we find that attackers can still execute malicious code inside a benign service worker due to a questionable practice employed by some websites during the service worker registration process. Here, we illustrate the questionable practice using a website that we found. Note that the code that we show is simplified, but without loss of generality. Essentially, this website utilizes URL search parameters during the service worker installation, and the parameters are used in the sensitive sync, which in this case is the import script function that can import and execute the specified JavaScript file. By executing the register function, an attacker can easily specify the vulnerable parameter to point to a malicious file, which may be hosted in a different domain controlled by the attacker. In this work, we consider such practice as service worker cross-site scripting. Moreover, this website directly uses location.search inside the register API. This can easily allow a web attacker to send a URL with a malicious parameter to a victim and remotely compromise the victim's service worker if the victim simply clicks on the URL. As the installation is done stealthily in the background, the victim likely will not notice that the service worker is already compromised. To understand the prevalence of this problem, we first crawl the top 100,000 websites based on triangle ranking. In total, we found 7,060 websites with a service worker, and 2,525 of them use a parameter in the register function. Then, we developed a 10 tracking tool called SW Scanner. to track the parameter usage inside a service worker. SW Scanner is developed as a website that accepts two parameters: the URL search parameter used in the register function and the target service worker file. SW Scanner will first take the specified parameter, then it evaluates the service worker file inside its own service worker context. When a taint parameter reaches a sensitive sink, SW Scanner will log and report the taint string and the sink. We open source SW Scanner and the data we collected, which can be accessed at u.tamu.edu/SW Scanner. We refer to the details of SW Scanner implementation in our paper. In total, SW Scanner found 40 vulnerable websites. The left column shows the number of websites that specify a corresponding parameter type in the register function. The right column shows the number of websites that execute parameters inside a corresponding sink. Specifically, there are 367 websites with hash parameters, in which 4 of these websites use the parameters in the import script function. Similarly, there are 141 websites with a URL as a parameter, in which 35 of them are vulnerable. Lastly, there is one website specifying JavaScript as the parameter, which can directly get executed inside the service worker. This figure summarizes the information of these 40 websites based on categories. The y-axis shows the number of websites in the category, and the red number shows the monthly visits count in millions. We find that the media category has the highest number of vulnerable websites, followed by the shopping category. However, based on the number of monthly visits, the shopping and sports categories are the most affected, as there are 112 million and 185 million monthly visits, respectively. While our previous evaluation shows that an attacker can hijack a service worker, one question still remains, that is, how long can an attacker keep control of a service worker? To this end, we noticed that a service worker will get replaced automatically once its file is changed. We use the Wayback Machine, which archives our website snapshots, and download our snapshots of the website with the service worker. Because the Wayback Machine does not have a complete list of websites, we only managed to download 777 websites with 3,166 snapshots in total. Then, we compare the archive service worker file of each website's subsequent snapshot and measure the time it takes for a service worker file to get updated. This scatter plot shows the link between updates of service worker file based on website ranking. On average, a website updates its service worker every 40 days, while the median is 20 days, and the longest time without an update is almost 2 years. This signifies the problem of service worker cross-site scripting, as attacker can leverage a compromised service worker for a long period of time. To mitigate the service worker cross-site scripting, we suggest 2 methods. First, proper CSP configuration can largely mitigate the service worker cross-site scripting. By specifying the script src directive in the service worker file to only import trusted domain, it can mitigate 39 out of 40 websites that we found. But it will not mitigate websites that directly execute URL search parameters as JavaScript code. Second, use an alternative method to pass parameter to a service worker. Currently, the cookie store API is being developed to support access in the service worker context. Once this API is officially deployed, we suggest that websites should use HTTP-only cookie to pass these parameters instead. To summarize, our contributions are as follows. First, we discover a new cross-site scripting attack caused by a questionable practice followed by some websites to install a service worker. We term this class of attack as service worker cross-site scripting. Second, we develop a service worker scanning tool called SW Scanner to evaluate this problem in real-world websites. We found 40 websites are vulnerable, which include popular websites that have more than 100 million combined visitors per month. We open sourced our tool and collected data to help the research community of this domain. We hope that our work will be one of the initial steps that help strengthen the security of service workers and websites in the future. Thank you.